Hello everyone, I'm Rahul Gade, and this is the first video of our fine-tuning series where we are going to fine-tuning and build a different types of project which are suited for resume. Uh, Before going on screen, I want to explain what are the contents I'm going to explain in this video are first of all what is fine-tuning, where I have taken or built an image on Jack Sparrow from Pirates of Caribbean explaining what actually fine-tuning is with the RAG and prompting, and this will give a very clear understanding to you why fine-tuning is necessary. Then I will go and I have created a web diagram where I will explain what fine-tuning, what are the types of fine-tuning, and what fine-tuning we actually or the current trends are actually going towards. Then we will understand the pros and cons of fine-tuning, why basically fine tuning is required, and at the end we will know what different projects we can make with fine tuning the models. So what actually fine tuning is, it means training a model to generate a structured output for specific tasks. Here training a model doesn't mean that we are training a model from scratch, but you're training the model. What actually fine tuning a model is, fine tuning means we add a specific upweights on the model for performing, for curating for specific task. If I want to give an example, chat gpt has its base model and its fine tune, which are the instruct model, where the next token, if we directly give it, we directly put it on the server, it will just predict the next token. But how the curated prompt chat or how the curated output chat gpt is giving, it's because they have used the fine tuning with reinforcement learning and human feedback. So it's another type of fine tuning, but post training tuning, there are various approaches. How ChatGPT is fine tuned, it is take from pre-training to supervised fine tuning, then a post training where the reinforcement learning with human feedback is used. This is a topic for the next video, but today we are explaining the types of fine tuning. So fine tuning is divided into two types. One is full fine tuning, second is parameter efficient fine tuning. What full fine tuning? The whole model uh, given upon our structured data. This is good approach, but why we will not use this? Because it required very high computation power because you are retraining the model. Example, GPT-5 is nearly around 500 billion parameter model. Retraining 500 billion parameter is will use parameter efficient fine tuning. It has LoRa and QLoRa are the two most popular technique, where QLoRa is we will use. So LoRa stands for lower rank adaptation, where it will basically add another weights on the given weights, and that add frozen weights are remaining frozen all time, and we will just at the end merge these to both weight. As LoRa increases the speed of fine tuning the model, and the QLoRa is the quantized version of LoRa, where the quantization techniques like NF4 in the 4 bits, so it will take very less amount of RAM. So this is what we will explain in depth in the next video. So for explaining the fine tuning, this is an image from Pirates of Caribbean. So fine tuning is used for specific tasks, but RAG, the goal of the RAG is that you are feeding your LLM to an external database, read that external database and curate the result. And the prompting is like you will just prompt the LLM that you have to do this. We actually had to move for fine tuning. Prompting means that you doesn't have an excess amount of data for fine tuning the model. But fine tuning is that you are building a model for specific uh, tasks, and you have that much amount of data to fine tune your model. Since you can explain in one project, in that project I will explain what is the difference between the prompting and fine tuning and how it affect the result accuracy or result performance. So let's explain the training and fine tuning of models. Fine tuning the full model cycles remain on your sides. And it's the cons is that, yeah, fine tuning is quite get complex because you have to know the whole thing about how the models are, how the model architecture is, and how its model weights are. And it's also required a specific compute power and compute maintenance to ensure the timeliness and performance. The best part of the fine tuning, why I love, is that because the model can locally run on your system, you will not use any type of API calls, and the whole data of your thing is private. Like suppose if you want to build a model for any bank, which have to do the OCR. Then rather than calling to the open, sending the data to different server, we can just build a model or vision language model that takes the text and just remove the content from that image. And this is what the fine tuning is. So yeah, here is a question that can be different service provider. Yeah, you can definitely use it, but if you doesn't want to spend more price for the tokens, like just you have to remove the text from the script, from the image. You are sending one text, and this text where the Claude takes high dimensional images of that text and then remove the text. And this is what a few very much costly, where the tokens get consumed too high. So to avoid this, you can just take a model, compress the model into the 4-bit or 8-bit quantization using QLoRa and bits and bytes library. Then fine-tune the model on a specific amount of data set, and it would require access to the most advanced model and can scale used to increase. So this is what an image I have taken from Hugging Face explaining how the fine tuning is. You start with the idea of what your problem is, an OCR where just give a text, add the image and remove text will be removed from there. Then get the data ready for fine tuning purpose. For fine tuning, we mostly relies on supervised fine tuning approach where you has supervised learning algorithm and input data and output data, and the just the LLMs updates its weights or curate Hugging Face pre-trained model, train and fine tune the model, evaluate the model, and improve through implementation experimentations. Save and upload the model on Hugging Face faces and run a gradient inference. This is what a life cycle we will follow for all the next 4 to 5 projects. Now, what you can find, this all projects we are going to do. Where first is we are building an object detection model with RTDR. So RTDR is a model by Llama, not Llama Meta. They have released a real-time object detection model, and we will also fine tune on Polygemma, which is an open source computer vision and segmentation model by Google. Then we will fine tune as we will do, and LLMs like small VLLM, which is another class of vision language model having a parameters of 265 million parameters and released by Hugging Face. It's a very good model. We will build 2 to 3 projects here and possible. Also go with Gem. And this all projects I will do on Google Colab free compute power such that anyone can access. And this is what a video related to fine tuning. In next lecture, we will go into LoRa and how it affects. I will also explain what quantization basically is, and I will also give you some tasks to perform a quantization on given amount of data. Next lecture, definitely you have to watch it such that after completing the next lecture, we will directly move to ADR. Thanks for watching the video. Like, share, and subscribe.